All right, guys, so for chapter 2, we're actually going to get into writing proofs. And proofs is something that a lot of geometry students struggle with, and that's one of the reasons why they may or may not like geometry is because of proofs. But a proof is just kind of a logical thought process behind how we get from one true statement to another, kind of the flow of thought using rules and whatnot. So we're going to get into how to create a proof right now, but the best way for me to kind of logically show you and kind of show you what a proof is to use the game of Uno, which most of you guys know. So even if you don't know Uno, you can still follow along because this is a pretty great example, I guess, pretty easy way of showing you how a proof works. All right, so writing an Uno proof. Everyone knows in the game of Uno, you have these cards, and they're different numbers, different colors, right? And you know kind of the rules. So we're gonna go over those. But for writing an Uno proof, the rules of Uno are our postulates. So our postulates are our kind of rules. That's all you have to know what a postulate is for our purposes. Use the first card as the given. So we're gonna have a given and a prove. And I'll show you what that means. I know that doesn't make sense yet. Use the first card as what's called the given. Use logic, so what we know, how we know the game works, to list the order in which you would play the other cards to finally be able to get to the prove card. Justify your logic in a 2-column format. Okay, so I'll get to that in just a second. Here are the 3 rules of Uno you need to know. You can play a card of the same color. So if I have 2 reds, like these 2, if I start with 1 red, I could throw this red down. They don't have to be the same card, they just have to be the same color. Okay? You can also play a card of the same number. So if I had a blue 5 and a red 5, I could play the blue 5 and then I could throw the red 5 on top of it because they're the same number. So either same color, same number, or you can play a wild card at any time, and the purpose for our proof here is to change colors. That's what ours is. Okay, so that's the 3 rules you need to know. Uno cards can be same color or same number, or if you want to change the color, you can use a wild card. Okay, so those are the 3 postulates that we're going to be using in our proof. So the first thing I wanted to show you is in a proof, and I understand we don't know what that is yet. That's what we're going to get to. But in a 2-column proof, this is what it looks like. So we always start off with a statement called the given. Okay, and that's just a true statement. There's no question. It's a fact. That's what's given to you. And then you're asked to arrive at a proof. So given this is true, you have to prove that this is true, right? And we're gonna look at that in just a second. So to set up our 2-column proof, you're gonna have 2 columns, kind of like a T-chart. And the left-hand column always says statements, and these are facts. And then the right column says reasons, and these are the rules behind the facts. Okay, so we're not just gonna make up a reason and write something down, oh, because I felt like it. No, we're gonna use rules of geometry on the side of the reason. So I'm gonna show you what that means here in just a second. First card game we're gonna do is gonna be set up this way. You can follow along if you want, you don't have to. And we are going to start with this card right here. Okay, so we've got this card. We want to, wish I could back up a little bit. I wanna use these 4 cards to get to this card, okay? So I'm gonna start off with this blue 6. I want to end up at a yellow reverse. And the only cards that I have to use to get here are these 4 cards, all right? So my given, the thing that I start off with, the fact that I know is true, my given is that I have a blue 6 in my hand. So up here in the given, I write blue 6. The thing that I need to prove is true is this yellow reverse. Now I know that sounds kind of funny because normally we're proving like a situation, like in math, like given that this angle is equilateral, prove that all 3 sides are congruent, something like that. But this is how we're gonna do it. So we start off with the blue 6, we have to end up with the yellow reverse. And in between, we have to use these guys, okay? So going from here to here, knowing the rules of Uno, we can match same colors, same numbers, or we can use a wild card to change. What could I play next, right? Which card could I play next? Well, I don't have a 6, but I do have a blue card. So I'm gonna play this blue card next. Okay, so out of these 3 cards left, which one could go on this blue skip? Do I have another skip? No. Do I have another blue card? No. So the only one I can use is the wild card to change colors, and I'm going to change to yellow. So it doesn't matter which yellow I use, I just have to change to a yellow card. And once I have a yellow card, I can use this yellow card. And once I use this yellow card, I can get to this yellow card, right? So we just logically used our rules of Uno to get from one card to the next, putting these in order. So this is what I'm going to write here in my 2-column proof. So I'm going to put these here. All right, so I have my prove and my given. Given, I started with the blue 6. I had to prove the yellow reverse. I had to get there in steps. So the first statement in a 2-column proof is always your given. It's always what you start with. Because remember, we're going in logical order. So that's not the word blue 6. And the reason for statement number 1 is because that's what was given to me. So that's always, for any proof you're ever going to do, the first statement is always the given. So blue 6, given. Okay, what was the next thing I did? I used the blue skip. Okay, and my reason has to be one of my postulates, right? And remember, these were my postulates. So why did I use the blue skip card? Because it was blue, right? It was the same color. So my rule, that first rule that said they could be the same color, that's my reason. Why did I use the blue skip? Because it was the same color. Sorry, why did I use the, blue skip? Because it was the same color as the blue 6. Okay, what was the next card I used? The wild card. I'll say wild draw 4. Why did I use the wild draw 4? What was the rule that I had about the wild card? What does it say? I can use the wild card anytime to change the color. So I'm going to write change color. Okay, then after I used that draw 4, I used a yellow card. And really, it doesn't matter if we would have used the yellow 5 or the yellow 1. It doesn't matter. I could have used either one. I started with the yellow 5, so I'm going to put that down. Yellow 5. Why did I use the yellow 5? Because I had changed my color up here to yellow. That's what I used the draw for. I changed it to yellow. I can even put that. Change color yellow. So then I use the yellow 5 because it's the same color as what I changed my color scheme to. After the yellow 5, I use the yellow 1. Again, because it's the same color. And then finally, your last statement should always, always, always be what you're trying to prove. So I went from a yellow 1 to a yellow reverse. And this should match. This is my very reverse. Can I spell? I'm talking and not paying attention. I went from a yellow 1 to a yellow reverse because they are the same color. Why did I write yellow 1 here? Same color. Y'all know. Y'all are catching me. I'm tired. All right. So these are all my statements here in logical order. Blue 6, blue skip, wild, yellow 5, yellow 1, yellow reverse. The reasons why I did each of these steps was over here. Why did I have a blue 6 first? Because it was the given. Why did I then use a blue skip? Because it was the same color. Why did I use a draw 4? To change the color to yellow. Why did I use a yellow 5? Because it was yellow, because it was the same as what I changed it to. Why did I use a yellow 1? So it was the same color as yellow. And the yellow reverse, again, same color. So over here, these are our facts in logical order, and these are our reasons on the right-hand side. So we're going to do another one, just like that, a little more simple. All right, so we're going to do this guy, and this one's a little easier. It's got less cards. All right, we're going to start off with a blue 5, and then I'm going to give you 2 cards in the middle, and then we have to end up with a green 6, right? So logically, what order could I put these cards in, right? Well, I've started off with my blue 5. What's the next color? I don't have a 5, so then I have to use the same color, right? So I'd go blue 1. And I don't have another blue, but I do have a card that's the same number. I have a green 1. And since this is green, I can use my green 6. So I got from a blue 5 to a green 6 using my cards and all the rules that I know of Uno. So up here, I'm going to put for my top blue 5 because that was the given. The next card I used was a blue 1 because they're the same color. The next card I used was the green 1 because that middle rule that I had here was that I could play the same number. These are my 3 rules. Same color, same number, or a wild card to change the color. So the green 1 was the same number. And then lastly, I had this green 6. And this last statement should always match your prove. Always. But the reason isn't because of prove, right? The reason has to come in logical order. So why did I go from a green 1 to a green 6? Because they are the same color. So all the facts, everything, all my steps that I did over here on the left, and then all my reasons why, my rules that I used, go here on the right. And you're not writing out sentences like, well, I felt like I needed to use the same color. No, you're just giving the rule. Whatever the rule is, that's what you're writing down there. Okay, so we got from the blue 5 to the green 6 using our steps. Let's do another one. All right, this one's gonna have 4 cards in the middle. I'm gonna start off with a blue, there it is, blue 7. I have to end up with a red 9. And the 4 cards I'm gonna use in the middle are these guys. Okay, so none of those are the same color. What do I do? What card can I use after a blue 7? Do I have any blue cards? No. Do I have any 7 cards? Yes, I do. So I'm going to use this green 7. After I use the green 7, do I have any more 7s? No. Do I have any more green cards? Yes, I have this green 4. Do I have any green cards left? No. Do I have any 4s left? Yes, this guy. And then the last card that I have to play is this 9. It is yellow, so I can play it. And since it's a 9, I can play this red 9. So I got from a blue 7 to a red 9 using these cards in logical order. I just used my steps, right? My rules. So then I just got to fill that out here. The given was blue 7. And then my reason for step 1 is always because it was given. Then I had a green 7 because they were the same number. After the green 7, I had a green 4 because they're the same color. And I'm writing same color here because that was one of my 3 rules. For anybody not paying attention earlier, I'm using these 3 rules. These are the only choices I have for my reasons here. You have to use rules for reasons. So same color, same number, or wild card to change the color. Okay, after my green 4, I used a yellow 4 because they are the same number. And after the yellow 4, I used a yellow 9 because they're the same color. And then lastly, I had to use the red 9 because they were the same number. So the things that you always kind of use as parameters or like as guidelines is the top. You always want your given statement on the very first line, and the reason is always given. And then the very last statement has to match your prove. This guy right here is what we were trying to get to up top, right? We were trying to prove red 9, we got to red 9. This will not match prove. You won't write prove here like we wrote given here. You won't write prove here. Here you have to tell me why. What reason did you have from going from yellow 9 to red 9? They were the same number. I should have wrote the number sign. Okay, hopefully this is making sense. I got a couple more. I got 3 more. This next one is the same length as that one. Okay, Given a red reverse, we have to prove a green 9. So here's my cards. Start off with a red reverse. I've got my green 9 I have to end up with, and then I've got these 4 cards in the middle. So which one could I play first, right? I'm starting off here at red reverse, so I can either use the same number, same color. I don't have another reverse. Do I have another red? Yes, I do. So I'm going to use this guy right here. After the red 3, do I have another red? No. Do I have another 3? Yes. I've got this blue 3. Okay, after the blue 3, do I have another 3? No. Do I have another blue? No. But I do have a wild card, so I'm going to change to green. And after I change to green, I can put this green 5 down. Once I have the green 5 down, I can use the green 9 because they're the same color. So I got from the red reverse to the green 9 using these 4 cards in the middle. Now I just have to write all that down. And I know this is monotonous, but I'm just hoping that it's a good way to get you guys to remember how to do it, okay? So top line's always the given. Red, reverse. What's the reason? Because it was given to us. Then I went to the red 3 because it's the same color. Then I went to the blue 3 because it's the same number. Then I went to the wild card because I wanted to change my color. And I wanted to change to green. And then I used my green 5 because it was the same color as what I just changed to. And then lastly, I used my green 9 because it was also the same color. Okay, hopefully that's making sense. Yet another Uno step. Hope it's clicking and everyone's going, oh yeah, this is easy, I get it. Because perfect, awesome. I hope that's the case. Last 2. All right, this one's a little bit longer. We start off with a yellow 8. Uh-oh, did I put them in the wrong order? And I have to prove a blue 1. That's this one, okay, cool. So I start off with my yellow 8. I have to end up with this blue 1, and I've got these 6 cards in the middle that I have to use. So I'm gonna hold them right here. Okay, so logically, let's start off here. I've got a yellow and a blue, and I've got yellow and blue cards here. I don't have an 8, so it looks like I'm gonna have to start off with the yellow. So I'm gonna use this yellow skip because it's the same color as my 8. I don't have another yellow card, but I do have a skip card. We'll call them the same number. They're the same card. Even though they're different colors, they're the same number. Then I have another green card, a draw 2. Again, same, no, never mind, not again. It's the same color, not same number. Then I've got a red draw 2. Then I've got a red 5. And then I've got a blue 5. Once I have my blue 5, I can use my blue 1. So they've logically progressed. Here to here, same color. Here to here, same, we'll call it same number. Here to here, same color. Here to here, same number, same color, same number, same color. So I just use same number and same color, no wild cards. So when I write all these down, because this is the most important part, is writing it down, getting you guys to remember how to do that. Statement number 1 is the given. So I started off with the yellow 8. And that's because it was given to me. And then I had a yellow skip because it's the same color. And then I had a green skip because they were the same, we'll call them the same number, even though they're not a number. Same face value, whatever. My rules only say number, so we'll say these are the same number. Then I had a green draw 2 because they're the same color. Then I had a red draw 2 because they're the same, whatever, the same face value, right? Same number. Then I had a red 5 because they're the same color. Then I had a blue 5. Oops, sorry, I didn't know you could see. Because they're the same number. And then lastly, I ended with my blue 1 because it's the same color. So sometimes in geometry, when you're doing a proof, they're not all this simple, right? Sometimes you'll start off with something up here, and what it tells you to end up at, you're gonna be like, how do I do that? But you have to remember all of the rules that you've learned in geometry, and we're gonna start with some of those today. So you have to use those rules to get from logical step to logical step. I think doing it, before we do geometry, we're gonna start with some algebraic, I guess maybe not start, but we're gonna work on some algebraic proofs. And everyone, all you guys know algebra, because you had to do that class before geometry, so it kind of makes a little bit more sense. Once we get into the geometry stuff, there's lots and lots and lots of rules you gotta memorize. All right, last one. It's a shorter one. Starting off with the yellow skip, this guy, ending up with a blue 3, this guy, and then we've got cards in the middle that we have to use here. And they're all 8s. Interesting. Well, neither one of these are 8s, so I'm thinking it's gonna be like a color deal, okay? So I have my yellow, same color. Now, this is an 8, so I could use any of these 8s. I know at the end I'm gonna have to have a blue, so I need to save that blue for the end. So it really doesn't matter if you do a red and then a green or a green and then a red, because either way is gonna be correct. As long as I use an 8 here and an 8 here, then I can use an 8 here, because they all have the same number. That's why I can use each of these. And once I get to the blue 8, I can use the blue 3 because they're the same color. Easy peasy lemon squeezy, right? So yellow skip. I'm gonna write down my steps first and then my reasons on the right. Yellow skip, yellow 8, green 8, and you could have done red first, that's fine. You could have switched steps 3 and 4. Blue 8, and a blue 3. Okay, so I went from top reason is always given. I went from here to here because they were the same color. From here to here because they were the same number. And same thing here, same number. And from the red 8 to the blue 8, same number. And then I went from the blue 8 to the blue 3 because they're the same color. So this is how a 2-column proof works. Once you understand the thought process behind this, then we can get into a paragraph proof. A paragraph proof is not a big deal. It's not something you're gonna have to do much of. Basically, you're taking each line and making it a sentence, and then you'd write a 6-sentence paragraph here. Basically, that's the easiest way I've found to do. So that'll be in the next little section of notes, but hopefully that helped you guys to kind of show you what a proof is based on Uno.